What's up, guys? Welcome back to the channel. We'll be doing this question paper that you see here. Now, this is a mathematics question paper for N4. It was actually test 2, which was the common paper for the following provinces, Gauteng and Free State. So this question paper, it consists of 4 questions. It has question 1, 2, 3, and 4. It was actually written on the 12th March 2026, and it took about 2 hours to be written. So we're going to start with question 1, and then we're going to do question 2, 3, and 4. On this particular video, though, we're going to start with question 1. So I'm going to leave the timestamps on each and every question of this question paper, just in case you don't want to watch the question in a sequence order. All right, people, before we start with this question, I'd just like to say thank you very much, guys, for watching, subscribing to the channel, commenting, and not forgetting those who like and share the videos. If you haven't subscribed to the channel, subscribe to the channel because I have lots of questions that I've solved here and other topics on Mathematics N4, also N5. So let's look at this question paper and let's start solving question 1. All right, guys, here's our question 1. Now, question 1 has 3 questions. So we're going to start with question 1.1, then we're going to do question 1.2 and question 1.3 in that order. So let me create space so that we can do question 1.1. Let's look at question 1.1 there. Let's first read the statement. Now the statement goes like this. Using the compound angle formula and your calculator, prove the following identity. So here's the identity they want us to prove there. We are given sine 180 degrees plus theta is equaling to negative sine theta. Now we've been given a hint that we should use a compound angle formula, and also you can use a calculator to prove this identity. So whenever you prove this type of identity or any type of identity, you must always select the side which looks complicated. When I look at this here, the left-hand side is the one that looks complicated. Remember, we need to use compound angle formula. If you still remember, the compound angle formula for sine, it goes like this. If you have sine, let's say A plus B, which what we have here, when you expand this is going to be sine A multiplied by cos B plus sine B multiplied by cos A. Then from there, you work on it. So as you can see here, let me just do this very quickly. As you can see, we can say 180 is A, and we can say theta is B. So we have to choose the one on the left-hand side. So let's do it. Right, so we have sine 180 plus theta there. Now, if you expand this, this is going to be sine 180 multiplied by cos theta, because 180 is A and theta is B. And then we say plus them, right? And then this time around, it's going to be sine theta multiplied by cos 180. There we go. Now, remember they say you can use your calculator here. So if you use your calculator and then you press sine 180, this is going to give you 0 there. And then multiply by cos theta, the cos theta that we have there. Plus, right, we have this sine theta multiplied by cos 180. If you use a calculator, cos 180 is going to give you negative 1 there. So if you continue, the first term there is 0. And then the second term, we have sine theta multiplied by negative 1. So our final answer is going to be negative sine theta. Therefore, we can say the left-hand side is equaling to the right-hand side, because of the right-hand side from the question is equaling to negative sine theta. Guys, you're supposed to use the compound angle identities, and also you can use a calculator. Just in case you don't know much about the compound angle identities, you can go to the description. I'll leave a video where I actually introduce the compound angle identities. Go and watch that video, and also that video will pop up on the top right of this video. All right, guys, we are done with 1.1. If this video helped you to understand how to solve this problem, you can always like the video, subscribe to the channel if you haven't subscribed, share the video to your friends, and also comment if you have any other comment. We are done with 1.1. Let's do 1.2. All right, guys, here is our 1.2. Now, here we are given this problem. They want us to prove that the left hand side, which is all of this, right, is equaling to the right hand side, which is actually -1. Again, just like the first question of this question paper, you always choose the side which is complicated when you look at it. Now, when you look at the left hand side, you can see left hand side is more complicated because the right hand side we only have -1. Now, in order for you to do this question here, you need to know special angles, guys. You need to use special angles, and also you need to use the 180 rule or the co-ratio rule. Now, this is up to you. Now, how are you going to do this? You need to expand each and every trigonometric ratio there that can be expanded. Let's start with the numerator there. We have cos 315. We can expand this by using the 180 rule. We can write cos 360 minus 45. Cos 360 minus 45, this can give us 315 degrees, right? And then we multiply. We have sine 210. We can write sine 180 plus 30 degrees, right? If you add 180 with 30 degrees, you will get 210. So I'm only using 180 rule because 180 rule is simple. Let's look at the third trigonometric ratio there. We have tan 225. We can write tan 180 plus 45. There we go. If you add 180 plus 45, you will get yourself 225. And then we divide them. Right? We are done with the numerator. Let's look at the denominator. Sine -45. So this one here, we can write as negative sine 45. The reason why we write as negative sine 45, sine -45 is actually happening on the fourth quadrant when you go backwards. Remember, when you go backwards, this here becomes negative theta then, right? So on the fourth quadrant, sine is negative. I hope you still remember that. Right, let's continue. Now, we also have cos 240. We can write cos 240 as 180 plus 60, right? If you add these two, 180 plus 60 is going to give you 240. We need to simplify this further. If you still remember, the cos diagram we have all here, which is represented by theta. We have sine and its inverse, which is cosec, which is represented by 180 minus theta. We have the third quadrant, which is tan, and its inverse, which is cot, is represented by 180 plus theta. And we have the fourth quadrant for cos, and its inverse, which is sec, which is 360 minus theta. This here is a 180 rule. So if you use the 180 rule, this is how we represent this quadrant. Now, let's look at cos 360 minus 45. This is the fourth quadrant. So cos on the fourth quadrant is going to be positive. So you can write as cos 45. There we go. Multiply. Now, let's look at the second trigonometric ratio there. We have sine 180 plus 30. That is the third quadrant. On the third quadrant, sine is negative. So it's going to be negative sine 30. There we go. Multiply by. Now, let's not forget this is multiplied. We have tan 180 plus 45. This is the third quadrant. When you say 180 plus, that's the third quadrant. On third quadrant, tan is positive. So it's going to be tan 45. There we go. And then we divide there. Right? When you divide, this negative sine 45 is still okay, people. And then let's look at this one here. We have cos 180 plus 60. That here, it's a third quadrant. On the third quadrant, cos it's negative. So we know this is going to be negative cos 60 there. So let's create space and let's continue here. Now, in order for us to continue here, guys, we need to use the special angles. Now, the special angles, we have triangles there. This is the first triangle. Now, let's use the other triangle. We only need these two triangles, by the way. So this here, guys, are these triangles that you need to know. Now, if you continue, let's look at the first trigonometric ratio on the numerator, which is cos 5. Now, cos, we know that it is adjacent over hypotenuse. So our cos 45 is going to be from this triangle here. So our adjacent for 45, we know that is 1, and our hypotenuse is going to be root 2 there, multiplied by negative sine 30. Now, sine 30, we're going to take it from this triangle here. We know that sine is opposite over hypotenuse. So the opposite of 30 is going to be negative 1 over. Now, our hypotenuse is going to be 2 there, right? Multiplied by. Now, what do we have here? We have tan 45. So tan 45, we're going to take it from this here. So tan, we know that it's opposite over adjacent. So our opposite is 1, our adjacent is also 1 there. So we divide them. Now we have also negative sine 45. So negative sine 45, we're going to take it from this triangle as well. So negative sine 45, we know that it's going to be 1 over root 2 because sine is opposite over hypotenuse multiplied by negative cos 60. Now, cos 60, we're going to take it from this triangle. Again, cos, we know that it is adjacent over hypotenuse. So our adjacent here is 1, and our hypotenuse here is 2. There we go. Let's not forget this is also negative. Now, if you look at this here, we have negative 1 over root 2 and another 1 over root 2 on the numerator there. We also have negative half, right? Divided by negative half. And then we have 1 over 1. That is going to give us 1. Let's not forget we are left with negative. So the answer here is going to be negative 1 there. I hope you guys managed to see this. It really wasn't not that difficult. But in case you do not know the basics of trigonometry, then this is going to be challenging. Just in case you want to know about the basics on trigonometry, you can go to the description. I left a playlist that contains the basics for trig, which I use here on this question here. So you can go to the description. You'll see that playlist. It has the 180 rule, the co-ratio rule. It has also the inverses and the special angles as well. Go to that playlist. You will see all this information. All right, people, we are done with question 1.2. I hope you guys managed to understand question 1.2. If this helped you to understand this question, do not forget to like, share, comment, and subscribe to the channel if you haven't subscribed to the channel. Right, people, let's move to the next question, which is question 1.3. All right, guys, let's look at 1.3. Now, 1.3, the one asked to determine without the use of a calculator sine negative 75. Now, this one here, guys, it will require us to use the compound angle identity again. Now, before you do that, though, you also need to know the special angles. So if you watch from question 1.1 to question 1.2, we're going to use most of the information that we use there, our special angles and also compound angle. So let me first start with the special angle. All right, guys, yeah, the special angles. For this one, we're just going to need special angles mostly. Before we do this one, you can write this question like this: negative sine 75. Now we have a right to write it like this because of this here, negative 75. It means that this is on the fourth quadrant and we are moving in a clockwise direction. So on the fourth quadrant, we know that sine is negative. Hence, we can write it like this. Then from here, we can use special angles to expand this. We can write negative at the beginning. Let's put this inside the bracket. And then we expand this. We can write sine. If we put two special angles together, which is 45 plus 30, this here is going to give us 75. And then from here, we can expand this. So we still have that negative there. Let us not forget. If we expand this using compound, we're going to write sine 45 multiplied by cos 30 plus, because we have plus between the two here, it's going to give us sine 30 multiplied by cos 45. Then we close there. Right. So from here, we can start using these special angles that we just write here from our triangle. Now, sine 45, let's not forget we have negative there. Sine 45, we know that sine is opposite over hypotenuse. So our opposite of 45 is 1. Our hypotenuse is root 2 from this triangle there. Right. Multiply cos 30. We know that cos is adjacent over hypotenuse. So cos 30, our adjacent is root 3 and our hypotenuse is actually 2. There we go. Plus. Now, we know that we have sine 30. Sine 30 also is from this triangle here. So sine is opposite over hypotenuse. So the opposite of 30 is 1 and the hypotenuse is 2 there. Right. Multiplied by cos 45. So we're going to take it from here as well. We know that cos is adjacent over hypotenuse. The adjacent of 45 is 1. The hypotenuse is root 2 there. Right. Let's not forget, we still have the negative there. So that negative, we keep on writing it as it is. We're going to multiply the numerator, 1 multiplied by root 3. This here is going to give us root 3. The denominators, we're going to multiply root 2 multiplied by 2. This here is going to give us 2 root 2 plus we have 1 multiplied by 1 on the numerator, so that's going to be 1. And then we have 2 multiplied by root 2 on the denominator. We're going to have 2 root 2. There we go. So let me create a little bit of space here so that we can finish our problem here, guys. Right. So if you continue like this, let's not forget that negative is still there. We can say root 3 plus 1. All this is divided by 2 root 2 because both root 3 and 1 are divided by 2 root 2. So we are allowed to do this. Right. So this is what we have. So from here, we can rationalize, guys. By rationalizing, we multiply by root 2 over root 2, which is the same as 1. The reason why we multiply by root 2 over root 2 is because we want to get rid of that root 2 there. So if you multiply by root 2 throughout, remember that negative, we can keep it here at the moment. So we're going to have root 3 multiplied by root 2. This here is going to give us root 6. And then we have 1 multiplied by root 2. This here is going to give us plus root 2. Divide by, right? And then we have 2 root 2 multiplied by root 2. This here is going to give us 4, like that. So the final answer here, guys, is actually negative root 6 plus root 2 divided by 4. Or some of you may write it as negative root 6 minus root 2 divided by 4. Pay attention. Look at my negative here, guys. It's exactly in the middle, just like this line. So this means that this negative affects everything. But if you decide to multiply by this negative throughout, it should be negative there and negative there. So the final answer is this one here. Again, people, this question, I've done something similar to this. If you want to know more about this, or if you want to see more problem on this, I'm going to share some videos based on this type of questions. There is a playlist where I've done this type of questions. I'm going to leave it on the description. Go and watch those videos in order for you to understand better. Again, that playlist contains the compound angle identities. So go and watch it in order for you to understand way much better when it comes to this. All right, people, if this video helped you to understand, do not forget to like, share, comment, and subscribe to the channel. We are done with question 1 of this question paper. We'll do question 2. All right, let's look at question 2 here. Now, question 2, it's based on graphs. So they want us to sketch these graphs that you see here. As you can see, question 2 consists of 4 questions with sub-questions there. All in all, this actually consists of 8 questions. So we're going to solve question 2, starting with question 2.1.1 until to question 2.4.1. 2.2. All right, guys. So let's start with question 2.1.1 and let's create space and solve it. Here is our question 2.1.1. Now the question here, they want us to sketch the graph of y is equaling to cot. And then they give us the restriction there. Here is our restriction here. It goes like this. X cannot be equaling to or greater than negative pi, and also x cannot be equaling to or less than pi there. So that is our restriction. So you need to know what exactly is pi in this case. Just in case you do not know what pi is, in this case, pi is actually radians. So we have to change radians into degrees so that we can work with something that we are familiar with. So in order for us to change pi into degrees, here's what you have to do. You multiply pi with 180 divided by pi. This here, guys, it's how you change from rads to degrees. Meaning now, pi over pi is going to give you 1 multiplied by 180. So this means pi is 180. Meaning now, negative pi is equaling to negative 180. So our restriction is from negative 180 to positive 180. So I'm going to use a red color to indicate this in degrees. So we can say negative 180. And then here we can say positive 180. Now let's continue. Let's look at this graph here. Now they want us to draw the chord graph. So in order for you to draw the chord graph, there are a few things that you need to know. We need to find the period, and also we need to find the intervals. So let's start by finding the period. Now there's this formula here that we use to calculate the period for the graph of tan and chord. It goes like this. Period is equaling to 180 divided by b. Now, if you're wondering what is b, b is a coefficient of x. As you can see here, we have y is equaling to cot x, right? So the coefficient of x is actually 1 there. So in this case, b is actually 1. So when we calculate for a period, it's going to be 180 divided by 1. So 1 full cycle is going to happen within 180 degrees. There we go. And then from there, we need to calculate the intervals. So this is the formula for tan and also cot to calculate the interval. So it's period divided by 2. So we already established that our period is going to be 180 and then 2. We divide by 2 there. So 180 divided by 2, that is going to give us 90 degrees. This means that from one point to another, we move by 90 degrees. So let me first draw the Cartesian plane so that we can draw our graph. All right, so here is our Cartesian plane. Before we continue, let's not forget that we have x here and we also have y there. All right, so let's start. So from the 0, 0 point, we have to understand that this is a chord graph. So with a chord graph from the 0, 0 point, this here is going to be the asymptote line. So I'm going to draw using this red line here, right? And then to the next point, remember we are moving with 90 degrees. At this point here, it's where we're going to intersect. And then the next point is going to be 180. So this is going to be asymptote line. That's it. So we stop at 180 because our restriction state that x cannot be greater than 180. It can also be equaling to 180. So that's where it ends then. So when you move to the negative side, at negative 90, we intersect. Remember, we're moving by 90. So the next point again is going to be negative 180. So what do we do then? We asymptote. This is an asymptote line. So I hope you guys know about this, how to draw the chord graph or tan graph. It's very similar. What happens is that we have the asymptote line and then we have the intersection for chord and then asymptote line on the next point and so on and so on. Because our restriction is from negative 180 to 180, so we cannot go beyond these 2 points. So from here, we start drawing our graph. So our chord graph, it is not like tan graph. From the point of intersection, you must move towards 0 point from the positive side of y, right? On the negative side of x, you're moving away from 0. Then you asymptote there. Okay, you must asymptote on the asymptote line. On the negative side of y, we are moving towards 0 underneath them. And also we asymptote on that point there. And also on this side here, on the positive side of x, we are moving away from 0 when we draw our graph underneath there. And then it asymptotes there. So in this one here is actually our cot graph. So you can name this graph here, y is equaling to cot x, and that's it. So this is the type of a graph that they were looking for, guys. I hope you know how to draw this graph. I haven't made videos on how to draw these trigonometric graphs, but when I have time, I will do videos on them. But this is basically how you draw this chord graph here. Now that we are done with this question, I hope you managed to understand, guys. If you did not understand, please leave a comment on the comment section. And also, if you manage to understand, don't forget to like, share, comment, and subscribe to the channel. Let's move to the next question, which is 2.1.2. Now, let's look at 2.1.2. Here is our 2.1.2 there. Now, let's read the statement and let's solve for this question here. The question goes like this. At which point, if any, is y is equaling to cot x, and then they give us the restriction there, which x is equaling to or greater than negative pi, or equaling to or less than pi. We can also say it in this manner: x is equaling to or greater than negative 180, and x is equaling to or less than 180. They want to know at which point our function y is equaling to cot x is going to be discontinuous. In order for us to find that, we need to do the following. We know that cot is cos x divided by sine x, right? This here is what we call the quotient identities. When we use this, we have to equate our denominator, which is sine x, with 0 and solve for x. So let's do it. So if we say sine x is equaling to 0, x is going to be arc sine 0. Arc sine is when you take sine to the other side there, guys. And then x is going to be 0. But this is not the only point. This is one of the points. The other point, it's supposed to be 180 minus 0 and negative 180 plus 0. So this means that this is going to be 180 and negative 180. Remember, for a function to be discontinuous, it should be divided by 0 when you substitute them. So we are actually dealing with sine there. If we substitute x there, which is 0, this is going to give us 0 there. Also, if we substitute 180 there, that is going to give us 0. Also, if we substitute negative 180 there, that is going to give us 0 there. So at these 3 points here, where x is 0 and 180 and negative 180, these are the points where our function is going to be discontinuous. Guys, I hope you understand this. This is actually N5 work. So this question was actually not part of the syllabus for N4s. But just in case you wanted to know the answers, these are the answer for this question. Guys, I hope you managed to understand this one as well. If you do not understand, don't worry much about it, because this is actually N5 work. But you can leave a comment on the comment section, and I'll try to explain to you to my level best. But if this helped you to understand, do not forget to like, share, comment, and subscribe to the channel. All right, guys, we are done with 2.1. Let's look at 2.2. All right, guys, let's look at 2.2. Now, 2.2, it has 2 questions here. We have 2.2.1 and 2.2.2. So 2.2.1, they want us to sketch the graph of y is equal to 2 multiplied by 3 to the power of 2x. This here, guys, is an exponential graph. How do you know? Because x is the exponent there, just in case you can't figure it out, right? So the exponential graph, guys, in order for you to draw it, I always recommend that you use the table, even though they do not mark the table, but it's easier that way. So let me first create a table, and then let's draw our graph. All right. So let's look at the x entries then. As you can see, I have -1 and -0.5, and then 0, 0.5, and +1. These entries, guys, they are actually your choice. I prefer that we use the smallest number when we insert the x values there, because if you use the bigger numbers, you might get a very huge graph, guys. So the best way is to use the entries that are very small when it comes to numbers. So I hope you guys can able to understand that. So let's start. If x is -1, what is going to be our y? Now, if we write our y there, it's going to be 0.2 there, right? Yeah, rather leave it in a decimal point so that we can able to draw it on our graph. Now, let's look at the next point there. When x is actually -0.5, what is going to be our y there? Our y is going to be +0.7. So 0.7, that is going to be our y. Then when our x is actually 0, what's going to be our y there? So our y is going to be actually 2. There we go. Now, when our x is actually 0.5, what's going to be our y? Our y is going to be 6 there. And then when x is actually 1, what is going to be our y? Now, if we put that on a calculator, it's going to give us 18. As you can see, people, the reason why I said you must insert less or small numbers on x is because the bigger number will increase our y. As you can see, as we move to positive, our y becomes bigger from 2 to 6, from 6 to 18. That is exponential growth there. So if you put bigger numbers there, it's going to be way too big. So from here, let's draw our Cartesian plane, and then we can able to draw our graph. All right. So as you can see, here's our Cartesian plane, guys. Now, if you can look at y, we have the multiple of 6, and for x, we have the multiple of 0.5. So it doesn't really matter that much how you do your multiple, but make sure that you don't make your graph to be big, guys, right? So let's start at this point here. When x is -1, our y is going to be 0.2. So we know that x is -1 here. You take a ruler, you draw a line, and then our y is supposed to be 0.2. 0.2 is very close to 0, so you can just draw a line here very close to 0, and then wherever they meet, that here is your point there. Now let's move to the second point. When x is -0.5, our y is going to be 0.7. Again, -0.5, it's here. You draw a line here using your ruler, right? And then y is supposed to be 0.7. 0.7 should be a little bit up here. Now draw a line from there, and then wherever they meet, this here is going to be your point. Now let's look at point here. When x is 0, our y is going to be 2. So we can say 2 is somewhere there, guys, right? So when x is 0, our y is 2. Let's say 2 is right there, right? And then let's look at the point where our x is 0.5, our y is supposed to be 6. So 0.5 is this one here. Let's go. And then 6 is supposed to be that one there. That's where they actually meet. And then the last point, when our x is 1, you draw a line there. Our y is supposed to be 18 there. There we go. This is the point there. Point there. Then you start connecting. Guys, it doesn't really matter these points that much. What matters is the shape and the y-intercept. Guys, this is our graph here. What matters is the shape and this intercept here, the y-intercept. So always write it 0 and 2. Make sure that you write it, especially if you don't have 2 on this one there. Write it on the side like this. All right. And then the shape as well is the one that matters the most. So we can say y is equaling to 2 multiplied by 3 to the power of 2x. So this here is our graph. Guys, I hope you managed to understand this. Like I said earlier, the x entries, you don't have to put big numbers. Just put the smallest numbers that you can think of. And also you can start from negative to positive part of the number that you started with, right? And all you have to do is substitute, you get your y values, and then you plot your graph using the points that you just gotten there. All right, people, I hope you understand this. If you do not understand, you can always leave a comment on the comment section and rewatch the point that you did not understand. And you can always like the video, share the video, subscribe to the channel if this helped you to understand how to draw the exponent graph. Okay, people, we are done with 2.2.1. Let's look at 2.2.2. Now, 2.2.2, it's 1 mark. They are asking this question here. Is y equaling to 2 multiplied by 3 to the power of 2x a function? Now, the answer here is yes, it is a function. How do you know? There is one method that you can use to find out. When your graph cuts the y-axis once, just know it's a function. In this case here, we can use that method to determine whether it's a function or relation. So the answer is yes, because this graph of ours cuts our y-axis once. If it cuts more than once, just know it's no longer a function, it is a relation. Okay, people, we are done with question 2.2. I hope you guys managed to understand. Do not forget to like, share, comment, subscribe to the channel if you haven't subscribed. If you got confused somewhere, rewatch at the point where you got confused or leave a comment on the comment section. Let's go and do question 2.3. All right, guys, here is our 2.3. Now, 2.3, it has two questions, which is 2.3.1 and 2.3.2. Let's start with 2.3.1 then. The one asked to sketch the graph of y is equal to 2 log x to the base of 1 over 3. Now, this here, clearly we can see this is a log graph. Again, log graph, it's one of the graphs that you can draw using a table. I prefer that you use a table to draw this graph. Now, if you use a table, there are a few things that you need to pay attention to. First, let's start by creating the table. All right. So when you draw the log graph, here are the things that you need to know, especially when you use a table. You need to know that x, it cannot be equaling to 0, and also x cannot be less than 0. So x cannot be equaling to or less than 0. That is not allowed. So whatever you're going to insert here, do not insert 0 or any number that is less than 0 for x. So we're going to insert 0, 5, 1, 1,5, and 2. I think these here, they are enough for us to actually draw our graph. Again, guys, this is optional. So my multiplication here is 0, 0,5. Some of you can use 0, 0,3, 0, 0,2. It really doesn't matter, guys, as long as one of the numbers here is less than 1. Right? So let's continue. Now, if we use our calculator here, when x is 0, 0,5, what is our y? So what I'm getting here is 1,3 there. Right. Now, let's move to the next point. When x is actually 1, what is our y there? This is going to give us 0. There we go. Now, when x is actually 1,5, what is our y there? I'm actually getting negative 0,7. There we go. And then the last one there, when x is actually 2, what is our y there? I'm actually getting negative 1,3 there. So guys, this is how you're supposed to do the table when it comes to log graph. Now let's draw our Cartesian plane and we can able to draw our graph here. All right, so here is our Cartesian plane here. So all you have to do is to plot this graph using the points here. Let's start with this point here. When x is 0, 0,5, our y is 1,3. So 0, 0,5 for x is this point here. So we draw a line there that is going upwards. And then our y is actually 1,3. 1,3, if you look at the y-axis, should be between 1 and 1,5. So this is in the middle. So we draw a line that goes this way. That is going to be our point there. Now let's move to the next point. When our x is 1, our y is 0. So this is the point here. Our x is going to be 1 there, but our y is 0 on the x-axis. Now let's move to this point here. When our x is 1,5, our y is negative 0,7. So 1,5 is here. You take a ruler, draw the line there. Our y is negative 0,7. Negative 0,7, if you can see on the y-axis, it's supposed to be in the middle between negative 0,5 and negative 1. So if I take a ruler, draw a line like this, and there is our point there. And then the last point, it goes like this. When our x is 2, our y is going to give us negative 1,3. Now, negative 1,3, it's also between negative 1 and negative 1,5. So we draw the line here. It goes this way. And then we draw a line from 2 on the x-axis where they meet. That is going to be our point. Then you start drawing your graph. So your graph is going to look like this. There we go. So this is our graph for this function here. Just in case, guys, you do not know, make sure that you know how to draw the shape. It doesn't really have to be a table like this. If you know how to draw this graph without using a table, it's also fine. Just make sure that the shape is fine and also this intercept is there. So I'm going to show it 1 and 0. These are marks for that. In this case, you can leave it like this because we can see it's intercepting at 1 for x. And then you label the graph there, right? Y is equaling to 2 log x base 1 over 3. There we go. So this here, guys, is our graph. It's how it's supposed to look like. I hope you guys managed to understand this because this really was not that difficult. It's just that sometimes when it comes to log, people forget this condition there. When you draw the log graph, guys, make sure that you do not have negative or 0 on your x interest there. X should be greater than 0. Shall not be less than 0 or equaling to 0. All right, guys, let's look at question 2.3.2. Now, the question goes like this. What is the range of y is equaling to 2 log x base 1 over 3? All right, guys, when they're asking for range, they're asking for the values of y at which our graph starts and where it ends. If you look here on the y-axis, guys, we can see that it does not have the ending or the beginning of this graph here. It goes forever when you look at the positive side of y, and also it goes forever when you look at the negative side of y. So you can say y is greater or equaling to negative infinity and y is less than or equaling to positive infinity. So this is how you write this question here, 2.3.2. Guys, I hope you managed to understand this one here because it was not really that difficult. Just in case you didn't understand, guys, you can rewatch at the point where you got lost. And if that doesn't help, you can always leave a comment in the comment section. I'll try to help you to my level best. Guys, we are done with 2.3. Do not forget to like, subscribe, comment as well if this question helped you to understand this type of questions here. Let's go and do 2.4. All right, guys, let's look at question 2.4. Now, question 2.4, it has two questions as well. It is 2.4.1 and 2.4.2. Now, we're going to start with 2.4.1 there. They want us to sketch the inverse of y is equaling to root 25 minus x squared. Now, this here, guys, is a semicircle, but they want us to draw the inverse graph of this semicircle. It is not that difficult, guys. All you have to do here in order for you to draw the inverse graph of this function, you just swap your x and y, meaning where there is x, you substitute with y, where there is y, you substitute with x. So let's do it. So this is equaling to y. So instead of writing y, we're going to write x there. And then we have the root underneath the root there, we have 25, right? Minus. Now, this is x squared. Instead of x squared, we're going to write y squared. So this is the inverse graph of that there. Now, in order for us to draw it, we need to find our radius. Remember, this here is actually from x is equaling to r squared minus y squared. There we go. So we know that r squared is actually 25. And then in order for us to find r, we have to root both sides. We know that r is going to be 5. So our radius here is going to be 5. So this graph is very simple, guys. Let me draw the Cartesian plane and then we plot the graph. All right. So here is our Cartesian plane. Remember, we are drawing this graph here. Now, before you draw this graph, remember this is a semicircle. Now, this semicircle is actually the one that is intersecting at x. How do we know? First of all, is equaling to x. Now, which side of x does this semicircle gonna intersect? It's gonna intersect on the positive side of x, because this here it's positive, just in case you did not know. So it's gonna intersect at positive 5 on y-axis, and also it's gonna cut at positive 5 on x-axis, and then it's also gonna cut negative 5 on y-axis. So when you draw this graph, this is how it's supposed to look like. So this here is our graph for the inverse here, which is x is equaling to root of 25 minus y squared. There we go. So this graph here is the one that they wanted us to draw them. Okay, I hope you guys understand this. If you don't understand, again, go to the point where you got lost and rewatch that point. And if that doesn't help, leave a comment. I'll try to help you to my level best. Right, if it helps though, don't forget to like, subscribe, and share the videos. Let's look at 2.4.2. Now here they want us to find what is the domain of this inverse graph here. So the domain, guys, is based on the x-axis. If they ask you about the domain, just know they want you to tell us where does the graph start and where does it end on the x-axis. If you look at our graph there, I'm going to use green. Our graph starts from here. At this point, when you look at x, that is 0, right? And where else do our graph end? It ends there at positive 5. So now, if you write your domain, let me just write it here. X is actually greater or equaling to 0, but less than or equaling to 5. So here is our domain, guys. You can write it like this. It's all good. Guys, I hope you managed to understand how to do this one. This is how you do this type of equation. If it so happened that you don't understand, do not forget to watch at the point where you got lost. And also you can leave a comment on the comment section if that doesn't help. But if this helps you to understand, guys, don't forget to like, share, comment, and subscribe to the channel if you haven't subscribed. We are done with question 2 of this question paper. We'll do question 3. All right, here is our question 3. Now, question 3, it consists of 5 questions with 2 sub-questions on 3.4. So all in all, this is 7 questions. Basically, question 3 is about differential calculus. So we're going to start with 3.1 and do 3.5 later on. So let me create space for 3.1 and let's solve it. Okay, guys, here is our 3.1. Now let's read the instruction or the question and let's start solving the problem. Now 3.1 goes like this. Determine the following limits. So we are given this expression here, which is limits, and they want us to determine what is the limit there. But we first start with direct substitution. If direct substitution does not give us a limit, we do simplification. If simplification also does not give us any limit, we move to the next step, which is divide with x that has the highest power. So let's start with direct substitution. As you can see there, our x is approaching half. So we're going to write limit x approaches half. And then we have x cubed minus x divided by x cubed minus 1 there. So wherever there is x, we substitute with half. So let's start with direct substitution. So here we're going to have half to the power of 3 minus half divided by half to the power of 3 minus 1. And then if you put this on the calculator, I got 3 over 7. As simple as this may seem, but this is our answer. If you do direct substitution and you get an answer, just know that this is the answer. I hope you guys managed to understand this. Really, it was not that difficult. All you have to do is to substitute there and get the answer. All right, guys, we are done with 3.1. How about we do 3.2? All right, guys, let's look at 3.2. Now, 3.2, we have this statement here. Let's read the statement and let's start solving the question. Now, the statement goes like this. Expand the following power to 4 terms by using the binomial expansion. Now, we are given this here, which is x minus 2, all of this to the power of 6. Now, they want us to expand this to the 4th term using binomial expansion. Now, if you still remember, when we expand this, guys, we have to know the formula. So here is the formula for binomial theorem. We have x plus h to the power of nth term. So we can expand this to the 4th term. So let's expand it. We have x to the power of n. That's the first term. The second term, we have n multiplied by x to the power of n minus 1 multiplied by h. That's the second term. The third term, we're going to have n multiplied by n minus 1 divided by 2 factorial multiplied by x to the power of n minus 2 multiplied by h to the power of 2. Then that here is the third term. Now the fourth term is going to be n multiplied by n minus 1 multiplied by n minus 2, all this divided by third factorial multiplied by x to the power of n minus 3 multiplied by h to the power of 3. Now, if you look at our question there, we have the following. We have x minus 2 to the power of 6 there. Now, we can say x is actually x, and then h is actually negative 2, and n is 6, the exponent there. All you have to do here, guys, is just substitute. Now, the first term, we have x to the power of n. We know that x is just x, and then n is 6 there. The second term, we have n, which is 6, x to the power of n minus 1. So n is 6, and then minus 1. This is going to give us x to the power of 5 there. Multiplied by h. Remember, h is negative 2 there, plus, and then we have another. The third term, we have n, which is 6, multiplied by n minus 1, which is 6 minus 1. That is going to give us 5 divided by 2 factorial multiplied by x to the power of n minus 2, which is 6 minus 2. That is going to give us 4 there as an exponent. And then we multiply by h squared, but our h is negative 2, then squared them. Then we move to the last term, which is the fourth term. Now, the fourth term, we have n, which is 6. We have n minus 1. That is going to give us 6 minus 1. That is 5. And then we have n minus 2. That is 6 minus 2. That is going to give us 4. And then we divide by 3 factorial. Multiply by x to the power of n minus 3. 6 minus 3, that is going to give us 3. Multiplied by h to the power of 3, which is going to be negative 2 to the power of 3, like that. So from here, we start using our calculators. The first term, we all know that it's going to be x to the power of 6, no problem. The second term, this is going to be minus because we have 6 multiplied by negative 2. That's going to give us minus 12 x to the power of 5. And then the third term, now things are going to be challenging. So use your calculator. So first of all, you have to insert all of this in your calculator, right? And then you write the answer. So when I do that, my answer is going to be 60 x to the power of 4. There we go. And then let's do the last term. Again, on the last term, we have to multiply all this or put this in our calculator, right? So if I put that in a calculator, what I'm getting here is going to be minus 160 x to the power of 3. So this here is our final answer. Guys, I've done videos on binomial theorem, so you can go to those videos. I will leave them on the description. I'll leave a playlist of those videos in the description just in case you didn't understand how I did this. But this is how you do this one here. Again, guys, if this helps you to understand how to solve this problem, do not forget to like, share, and comment. If you haven't subscribed, subscribe to the channel. But if you got confused somewhere, you can always watch at that point where you got confused. And if that doesn't help, leave a comment on the comment section. All right, people, we are done with 3.2. How about we go into 3.3? All right, guys, here is our question 3.3. Now, question 3.3, the one asked to differentiate y is equal to 2x squared plus 4 from the first principle. Now, when you differentiate from the first principle, there's a formula that we need to use. This is a formula that we need to use, guys. It's as follows. We have f of x prime, and then we have f of x plus h minus f of x. All this is divided by h. And then we have limit h approaches 0 like this. So this is the formula that we must use, guys. We do have our f of x. By the way, f of x is what is given to us, which is going to be substituted there. We also need to find our f of x plus h then. So in order for you to find f of x plus h, it's very simple. Wherever there is x, you substitute with x plus h. Here's what I mean. So your f of x plus h is going to be from the original equation. We have 2x squared. Instead of writing x, we're going to write x plus h. Then we square this plus 4, right? Then from here, we simplify this. So let's simplify or factorize. So you can do the following method. X multiplied by x, that's going to give us x squared. X multiplied by h multiplied by 2, that is going to give us 2xh. And then we have h multiplied by h, that is going to give us h squared. Let's not forget that we still have 4 there. Right, let me highlight them. So this here is our f of x plus h, by the way. Right, so don't confuse it with the 4 there. Right, so let's continue. Now we have to remove the brackets. If we remove the brackets, we're going to have 2x squared plus 4xh plus 2h squared plus 4. Now this here is our f of x plus h. It's the one that we have to substitute there on the original equation. All right, so let's continue. So when we substitute, let's do it here on top. We're going to have f of x prime, and we have limit h approaches 0. So wherever there is f of x plus h, we're going to substitute with this then. There we go. So let's do it. We have 2x squared plus 4xh plus 2h squared plus 4. This is our f of x plus h then. But let's not forget, this is minus by f of x. So minus f of x. But our f of x is our original equation there, which is 2x squared plus 4. There we go. And then close bracket, divide by h. Please do not forget to do this because that's the common mistake that people do. This negative here, they forget to include the brackets. Make sure that you include the brackets, but that negative is going to affect everything. Now let's move to the next step. Now if you continue, we have f of x prime, and then we have limit h approaches 0. And then here we're going to rewrite our f of x plus h. So this is going to be 2x squared plus 4xh plus 2h squared plus 4. And then we remove the brackets by multiplying with negative. We're going to have negative x squared minus 4. Divide by h. There we go. So let's continue. Now, if you look at the numerator there, we must have some light terms. So we do have light terms, guys. The light terms that we have, there are terms that don't contain h. So we have 2x squared. So we have positive 2x squared and negative 2x squared. If you continue to the second term, we have 4xh. We leave that one. It has h. The third term, we have 2h squared. We leave it as well because it has h. But we also have the last one, which is positive 4. we must have the counterpart of positive 4, which is negative 4. They will cancel each other. So what you're left with here, you should be left with only terms that contain h. If there is a term that does not have h and it's here on this step, just know that you've made a mistake here. All right, so we're left with 4xh and 2h squared. So those are the two terms that we're left with. Now from here, what can we do is we take out the common factor on the numerator. So let me create space so that you can able to do this. Right, so we continue, right? F of x prime, limit h approaches 0. Now if you take out the common factor there, which is h, we'll be left with 4x on the first term. On the second term, we'll be left with 2h. All this is divided by h. Now h and h, they're going to give you 1. Now what you're left with here, we're left with f of x prime, limit h approaches 0. So you're actually left with 4x plus 2h. Now that we are left with this, we can start substituting 0 wherever there is h, because our h approaches 0. So you can write it like this: f of x prime is equaling to 4x plus 2. Wherever there is h, we substitute with 0. So our final answer is actually 4x. That is our final answer. Guys, I hope you managed to understand this. It was long, but it's something that we've done during our matric years. But just in case you didn't understand or you forgot how to do this, I have videos, playlists, especially for this type of problems where we differentiate from the first principle. But if this video helped you to understand, do not forget to like, share, comment, and subscribe to the channel if you haven't subscribed. Guys, we are done with this question here, which was 3.3. Let's go into 3.4. All right, guys, here is our 3.4. Now, 3.4, we are given there y is equaling to open bracket x minus 1 close bracket, another open bracket x plus 5 close bracket, all this to the power of 2. So we are given this expression here, and then they want us to solve 3.4.1 and 3.4.2. Now let's start reading 3.4.1. They want us to calculate using differentiation the coordinates of the maximum and the minimum turning point. Now here they want us to calculate the coordinates of these turning points. Now, first of all, we need to simplify this further. If we continue, we have y and then we have x minus 1, right? We can simplify this. We can say x multiplied by x is x squared, and x multiplied by 5 multiplied by 2, that here is going to give us 10x, and we have 5 multiplied by 5, that is going to give us 25. And then we have to FOIL and remove these brackets, right? So let's remove the brackets. X multiplied by x squared, that is x cubed. X multiplied by 10x, that is going to be 10x squared. X multiplied by 25, that is going to give us 25x. There we go. And then we have negative 1 multiplied by x squared, that is going to give us negative x squared. Negative 1 multiplied by 10x, that's going to give us negative 10x. Negative 1 multiplied by 25, that's going to give us negative 25. And then we have like terms there. As you can see, we have positive 10x squared and negative x squared. We also have the following like terms. We have 25x and negative 10x. So let's continue. Now, when we continue here, the like terms will cancel each other. So x cubed does not have like terms, so we're going to leave it like that. But as for x squared, we have 10x squared and we have negative x squared. That is going to give us plus 9x squared. And then as for x, we have 25x and we have negative 10x. That is going to give us plus 15x. And then the last term here, it's a constant, which is going to be negative 25. There we go. So this here is our function. Usually they give us in this manner, but this time around, they just want to spice things up. So let's continue. Now, in order for us to calculate the coordinates of the turning point of this function here, we need to derive once and we equate this derivative with 0. So dy over dx is supposed to give us 3x squared, right? Plus, now if we derive the second term, that's going to give us 18x and then the last term is going to give us 15 there. There we go. But let's not forget this is equaling to 0. Now, if we can look at each and every term here, we have a common factor. We can divide by that common factor, which is 3 throughout. So if we divide with 3 throughout, you're going to have x squared plus 6x plus 5. All this is equaling to 0. Now we need to factorize this so that we can find the x coordinates. So if you factorize, two brackets there, we have x and x, right, for x squared. And the factors of 5, when you add them, they give you 6. It's actually 5 and 1, 5 and 1. If you multiply 5 and 1, you're going to get 5. But if you add 5 and 1, you're going to get 6. So plus and plus, because everything is positive then, equaling to 0. So we can say x is equaling to -1 and x is equaling to -5. Now we have the x coordinates for the turning point. It's time for us to find the y coordinates for the turning point. So when we find the y coordinates for the turning point, we can say when x is -5, what is our y, right? So we're just going to substitute this -5, which is x, from the original equation. Remember the original equation, it is this one here. Let me highlight it very quickly. The one that we simplified, it is this one here. So substitute them. So let's continue. We have y, wherever there is x, we're going to substitute with -5. Then cubed plus 9, -5 squared plus 15, multiplied by -5 minus 25. Now this here, if I put this on a calculator, what I'm getting here is actually 0. So this point here, we can say turning point 1, let's call it turning point 1. When x is -5, our y is going to be 0. Now, let's find the next turning point when our x is actually -1. What is the y coordinate there, right? We do the same thing that we did before, but this time around we substitute with -1 wherever there is x, right? So the second term we have 9 multiplied by -1 squared. The third term we have 15 multiplied by -1 minus 25. So all in all, this here, if I put it in our calculator, I am getting -32. There we go. Let me create space here so that we can able to solve this further. Right, so turning point number 2, right, we have the following. When x is -1, our y is going to be -32. There we go. So I hope you guys can able to see this. This is the first question, which is question 3.4.1. So that's where this question ends here. They just wanted us to find these coordinates, by the way, right? Let me go to that question so that you can able to see exactly the next question. Let me zoom down for now. Right. So people, I hope you know how to do this, because I've done these questions again on my playlist. I'm going to leave the playlist that contains this type of questions. In fact, I've done previous question papers, not the playlist. So go to the previous question papers. We have solved this type of questions before. So let's look at the next question. The next question here, they want us to use the second derivative to indicate which point are the maximum and minimum. So basically here, they want us to distinguish between these two turning points that we just got. Which one of the two is the maximum and which one is the minimum. So it's very simple. When you are distinguishing between these 2 points, you need to do the following. You have to do the second derivative. So let me first write the number here, 3.4.2. So you must second derive this equation. Now the first derivative, as you can see, is this one here. We have 3x squared plus 18x plus 15. So that's the first derivative. So let me just write it very quickly so that you can take it from them. So we have 3x squared plus 18x plus 15. Now the second derivative is going to be the following. It's going to be 6x plus 18. Right. Now, after the second derivative, when we check, we must substitute with the x values or the x coordinates of the turning point there, right? And if we get a negative, then it's going to be a maximum. If it's positive, then it's minimum. Let me show you what do I mean. When x is -5. What is our turning point there? Is it maximum or minimum? So let's check. We have this here. So we're going to have 6. Wherever there is x, we substitute with -5 there, plus 18. So this here is going to give us -30 plus 18. So all in all, this is going to give us -12. So this makes it to be maximum, right? Also, write it next to the turning point there. So meaning this here is going to be maximum. There we go. When x is -1, we have to substitute again. So dy squared over dx squared is going to be 6. Instead of inserting -5 this time around, we insert -1 plus 18. So here, this is going to give us +12. So this here is going to be minimum. So meaning this turning point here is going to be minimum. There we go. So guys, this is how you establish between the two. So that was question 3.4.2. I hope you guys managed to understand this. Remember, when you are checking for the turning point, which one is maximum, which one is minimum, the second derivative, and then you substitute these x values there of the turning point on the second derivative. If it gives you negative, just know it's maximum. If it gives you positive, just know it's minimum. Right, people, we are done with this question. Let's go and do the question 3.5. All right, guys, let's look at 3.5. Now, 3.5, they want us to differentiate with respect to x. Now we are given this polynomial, and they want us to differentiate this. So first of all, before we differentiate, we need to simplify the terms that need to be simplified here. So rather write everything there. The first term, it's fine. It can be differentiated. So let's rewrite it like that. And then we have the second term, which is ln x to the power of 6. It's also fine. But the third term, we have 3 divided by cos. You cannot differentiate with the trigonometric ratio on the denominator. So we need to change this. So we can write this as 3. And then we can say sec x. Because 1 over cos x is the same as sec x. Just in case you did not know. These are reciprocals or the inverses. And again, if you want to know about inverses, there is a video on inverses. I'm going to leave it on the description, guys. Go and watch that video. And then let's do the last two. We have e to the power of x, and we have 2, and then we have x to the power of -1, right? When it's like this now, this we can differentiate. The last term, we cannot differentiate with x on the denominator, so we need to take it to the numerator as well. So the exponent is going to be -1 then. So let's start differentiating. dy over dx, right? The first term we have -2, which is a coefficient. Now, what is the differentiation of cot? If you still remember from your formula sheet, it's going to be negative cosec squared x. There we go. And then let's look at this one here. We have ln x to the power of 6. When we differentiate this, we have this formula here. When we differentiate ln, remember, if you're given ln to the power of x to the power of n, like that, let's say you have k as a coefficient, the differentiation here is going to be as follows. It's going to be n multiplied by k divided by x, right? So in this case, our n is 6, so it's going to be 6. Our k is 1, so all this is divided by x, right? Also, I've done videos on this. Go to the playlist, guys, and check for the differentiation of natural logs. Then you'll find this type of equation that I just showed you there, right? And then we have -3 sec x. What's the differentiation of a sec? If you still remember from the formula sheet, the differentiation of sec is going to be sec x multiplied by tan x. And then we move to the second last term. What's the differentiation of e to the power of x? Guys, e to the power of x is e to the power of x. This is an exponential differentiation. Again, you can go to the playlist and check the exponential differentiation. Guys, I've done this before. And then as for this one here, the last term, The differentiation here is a standard differentiation. We first have to write the coefficient, which is -2. And then remember, we multiply by the exponent, which is -1. And then we have x to the power of -1 minus 1. There we go. So let's simplify everything further. The second term here, we have -2 multiplied by negative cosec squared. It's going to be 2 cosec squared x, right? And then the second term is just 6 over x. And the third term is just -3 sec x multiplied by tan x. And then the fourth term, it's going to be e to the power of x. And the fifth term, we have -2 multiplied by -1. That is going to give us +2 x to the power of -1 minus 1. That is going to be -2. Right, so this is our answer then. But you can always leave your answer like this. We have 2 cosec squared x plus 6 divided by x minus 3 sec x multiplied by tan x plus e to the power of x plus 2 divided by x to the power of 2. Usually, we do not accept it when you have the x with the negative exponent there. Rather, leave it like this to be safe, guys. So, by the way, this is how you do this type of a problem. I hope you guys managed to understand. Just in case you did not understand, go to the point where you got confused or got lost, rewatch at that point. And if that doesn't help, you can always leave a comment on the comment section there, and I'll try to help you to my level best. Guys, if this type of a video helped you to understand, do not forget to like, subscribe, share, and comment as well, right? And then if you haven't subscribed, subscribe to the channel. I also have done these polynomials, so I will leave the playlist of these polynomials if you want to watch more about the polynomials similar to this one. All right, guys, here is our question 4. Now, question 4 is integration. It consists of 6 questions and 2 sub-questions there. So all in all, question 4 actually has 8 questions. So we're going to start with 4.1, and then we're going to continue to 4.6. So let me create space so that we can do 4.1. All right, guys, here is our 4.1. Now let's look at this question and let's solve it. As you can see here, they want us to simplify the following integral there. So what we need to do here, guys, is to first deal with what we have here. We have cos squared x minus sine squared x. This here, guys, is a double angle identity. So we need to simplify this one first. So let's simplify. So we're going to have sigma, and then we're going to write cos 2x dx. Remember, cos squared x minus sine squared x. That is a double angle identity for cos. Just in case you don't know much about double angle identities, I will leave a video on the description, and the very same video will pop up on the top right of this video that you're watching at the current moment. Go and watch that video to understand how we got to this cos 2x. Now that our expression is like this, we can start to integrate. Remember, when you integrate the trigonometric ratio, you first write the integral. So what's the integral of cos here? We know that the integral of cos is going to be positive sine 2x, right? Let's not forget 2x there. But since our x is the coefficient, we must divide by that coefficient, which is going to be 2 plus c. So this here, guys, is our final answer for this question. So I hope you managed to understand it. Just in case you did not understand, do not forget to ask on the comment, and also you can watch at the point where you got lost there. But this was straightforward as it seems here. If this helped you to understand, do not forget to like, share, comment, and subscribe to the channel if you haven't subscribed. Let's move on to question 4.2. All right, guys, let's look at 4.2. Now, 4.2, they want us to evaluate this definite integral that you see here. We need to integrate each and every term here before we actually evaluate. So when you integrate this, ln 3 is a constant. So remember, when you integrate the constant, you multiply by the variable that you're integrating with. In this case, it's actually x. So this is going to be x ln 3 minus 1 over x. that is actually the integral of natural log. So this is going to be ln x. There we go. But let's not forget we have the upper limit, which is 4, and the lower limit, which is actually 2, right? And then from here, we can start separating these brackets. We have y, which is going to be equaling to open bracket, x ln 3 minus ln x. This here is for the upper limit, that for them, minus. And then for the second bracket is for the lower limit, which is going to be x ln 3 minus ln x. Guys, don't confuse these limits with the powers here, guys, right? So this limits is to show that the first bracket is for the upper limit and the second bracket is for the lower limit. Then we can start substituting. If we substitute here on the first bracket, we're going to substitute wherever there is x with the upper limit. In this case, that is 4. So 4 ln 3 minus ln, instead of ln x, it's going to be ln 4. There we go, minus. And then here, instead of substituting with x, we're going to substitute with 2 there. It's going to be 2 ln 3 minus ln 2. There we go. And then you put this on a calculator. When you put this on a calculator, your answer is going to be 1,504 unit square. There is our answer. Guys, these are definite integrals. Just in case you want to learn about definite integrals, there is a playlist. I'm going to leave it on the description. Go and click on that playlist, and the very same playlist will pop up on the top right of the video that you're watching at the current moment. Go and watch the videos on definite integrals. All right, people, if this video helped you to understand how to solve this type of a problem, do not forget to like, share, comment, and subscribe to the channel if you haven't subscribed. But if you couldn't understand, you can always rewatch at the point where you got lost, and you can leave a comment on the comment section, and I'll try to answer you to my level best. But this is how you do 4.2. Now that we are done with 4.2, let's go and do 4.3. Here is our 4.3. Now 4.3, it has this sub question that we have here. Now let's start by reading the question on 4.3. Now 4.3, they say consider the graph of y is equaling to x squared plus 2. Now 4.3.1, they want us to sketch and indicate clearly the area enclosed by the graph of y is equaling to x squared plus 2. Now we also have the coordinates there. We have x is 0 and x is 2. Also indicate the representative strip used to calculate the indicated area. So here we are given this graph here, which is a parabola, and then they want us to draw that graph. Also, they want us to indicate the area that is formed by these 2 points, 0 and 2, on our x-axis. So let's draw the graph, and then let's indicate this. Now, before we draw the graph, we need to find the coordinates of this graph. So let's start with when x is 0, what is our y? So we're going to take this equation here. Wherever there is x, we substitute with 0. So y is going to be equaling to, wherever there is x, we substitute with 0, and that is squared plus 2. So we can say this here, our y is going to be 2. So we can say point A, when x is 0, y is 2. Let's do the next intercept. When y is 0, what is x, right? So this time around, wherever there is y, we're going to substitute with 0. So we're going to have 0 is equaling to x squared plus 2, right? Then from here, we're going to transpose this. This is going to be -2. This is x squared. After transposing 2 to the left-hand side, the next step here, we root both sides here. Now, if you root both sides, this is going to be error, because the square root of negative number is an error. So our x here is error. So don't worry, guys, if it's error like this, this means that we do not intercept on x-axis with this graph. We know that there is no interception on x-axis, let's find the turning point because this is still a parabola. So in order for you to find the turning point, there is this formula: x is equaling to negative b over 2a, right? So look at our equation here. We have x squared plus 2 there. We only have a and c there. Now that we don't have b, we can just put 0 there. So x is going to be negative 0 over 2. Our a is 1. So x is actually 0 there, meaning y is going to be 0 squared plus 2 from the original equation. So y is going to be 2. So our turning point, the coordinates for turning point, it's actually 0 and 2. There we go. Now, if you can pay attention, our turning point is the same as our point A there, the y-intercept. So let's draw the graph. With this now, we can able to draw the graph. So I'm going to draw the Cartesian plane here, and then we draw the graph. So here is our Cartesian plane. I hope you guys can see it. Now let's look at the points there. We have point A. Here's our point A. When x is 0, our y is 2. So this is going to be our point A there on our graph. And then we don't have the x-intercept. So meaning our graph won't intercept on the x-axis. But we do have the turning point here. Here's our turning point. It's similar to point A because when x is 0, our y is 2. This graph of ours should face upwards because a, the coefficient of x squared, is positive. So meaning our turning point is going to be there facing upwards. Now, when you draw this graph, guys, remember we don't have x-intercept, so our graph is going to be like this. It's going to go exactly past at 2, but it's going to face upwards like that. So this here is our graph, guys. This is the type of a graph which requires you to understand parabolas. But this is how the graph is supposed to look like. Now, we are not done because on this statement, they want us to enclose the area from 0. Remember, x is 0 here and 2 as well. I didn't put 2 there, so let's put 2 there. Let's put 2 there. Let's say 2 is here, right? There's 2 there. So we have to enclose our area. So from 0, this is going to be our 0 there, and 2 is going to be somewhere there. So we enclose our area there. And then they say we must highlight the area. So let me highlight very quickly. All right, so this is the area. Now, they also want us to show the representative strip. So the representative strip, you can put it anywhere between 0 and 2 on x-axis, and then show the strip there, right? So I'm going to put it here, change in x. So this question here, 4.3.1, this is what exactly they were looking for. Let's not forget to label this graph y is equaling to x squared plus 2. There we go. But this is exactly how they wanted us to draw this graph here. I hope you guys understood this. Remember, the area is from 0 to 2 on x-axis, which is from this point to that point on x-axis. Right, people, if this part of the video helped you to understand how to solve this type of a question, do not forget to like, share, comment, and subscribe to the channel. If you haven't subscribed, subscribe to the channel. And if you do not understand, do not forget to watch at the point where you got lost. And if that doesn't help, do not forget to leave a comment on the comment section. I'll try to help you to my level best. Right, guys, we are done with 4.3.1. Let's look at 4.3.2. Let's look at 4.3.2. Here's our 4.3.2. Let's read the statement. Calculate using integration the magnitude of the area indicated in question 3.3.1. So here they want us to use definite integrals to calculate the area of the one that we just created there on the graph. Hence, I left this graph here. So, in order for you to calculate the area, there are a few things that you need to understand there. First of all, we need to use the definite integrals. So with the definite integral, we have the upper limit and the lower limit. Now, where are we going to find those limits? Well, for this question, it's so simple. They are given to us. Remember, we have x, which is 2 there, the limit, and we also have x, which is equaling to 0. Those are our limit. So the bigger one is going to be our upper limit, which is 2, and then the lower one is going to be our lower limit, which is 0 there. Now, what you're going to put inside there is the equation of our graph there, which is x squared plus 2. There we go, dx. Now with this, you can able to actually calculate the area. So this is equaling to the area. So area is going to be equaling to, now we integrate everything that is inside there. So when we integrate x squared, this is going to be x squared plus 1 divided by 2 plus 1, right? Plus 2 is a constant. Remember, when we integrate the constant, we just multiply by the variable we are integrating with. In this case now, it's x. So this is going to be 2x. Then we close the bracket. Then we have the upper limit, which is 2, and the lower limit, which is 0 there. Now, let's simplify this one further. We have a, which is going to be, inside there, we have x cubed divided by 3 plus 2x, right? And then we have upper limit and lower limit. So I'm going to continue here on top. If you continue on top, we have to separate these brackets. The first one is for the upper limit, which is going to be 2 there, minus. And then the second one is for the lower limit, with the lower limit, which is 0 there. So what we have to do here is just substitute. So a is going to be equaling to, on the first bracket, we're going to substitute x with the upper limit, which is 2 in this case. So we're going to have 2 to the power of 3 divided by 3 plus 2 multiplied by 2. And then we close the bracket there, minus. And then on the second bracket is for the lower limit. We're going to have 0 to the power of 3 divided by 3 plus 2 multiplied by 0. There we go. And then when we use our calculator, on the first bracket, we're going to get 6.667 unit square. So this here is the area of this graph there, the one that we indicated in yellow. Obviously, this one's going to give us 0. Even if you don't write it, it's still fine, people. So I hope you managed to understand how to find an area when you're given a problem like this one. If this helped you to understand how to find an area, you can always like, share, subscribe to the channel if you haven't subscribed, and you can leave a comment as well. If it so happened that you do not understand, do not forget to also watch at the point where you got lost. And if that doesn't help, you can leave a comment on the comment section and I'll try to answer you to my level best. Guys, we are done with this question 4.3. Let's go and do the next question, which is 4.4. All right, guys, let's look at 4.4. Now, 4.4, they want us to integrate the following there. Now, you must make sure that we simplify each and every term before we integrate. So, while we are simplifying, we keep the sigma, and then we simplify the terms. Let's start with the first term. The numerator on the first term, we have sine 2x. That is a double angle identity. You can always write it like 2 cos x multiplied by sine x divided by cos x. Let's write cos x there, minus. And then we have 2. This one here, we have the sides or sets. So we can change that into exponent. We know that a root is the same as the power of half. There we go, minus. We have 3 there, plus 1 over a, minus 3 cos, and then we have x over 3, minus 3 to the power of negative 4x, like that, dx, right? So we are not finished because the second term, we still have x to the power of half on the denominator. So we need to take this to the numerator before we integrate. So we're going to continue and rewrite everything as they are. On the first term, we also have cos x divided by cos x. So we're going to be left with 2 sine x, right? Minus. 2, the coefficient. Now, if you take the x to the power of half on the denominator to the numerator, our exponent there is going to become negative half. Then minus 3 plus 1 over a minus 3 cos x over 3 minus 3 to the power of negative 4x. Then we say dx. Then, now that each and every term is simplified, we can start to integrate. So let's do it. Y is going to be equaling to the first term we have 2 sine x. The integral of sine, we know that is going to be negative cos. So we have 2, the coefficient, multiplied by negative cos x. There we go. Right, the second term is a standard integral, guys. So first we have to multiply by the negative 2 there, the coefficient. And then from there, we have x to the power of negative half plus 1. Then we must divide by the very same negative half plus 1. There we go. And then we move on to the next term. Now, the next term there, we have negative 3, which is a constant. When you integrate the constant, you multiply by the variable that you're integrating with respect to. In this case, it's x. So it's going to be 3 multiplied by x. There we go. Plus, we have also 1 over a. That is a constant because you don't have x there. So we have to multiply by x as well. So 1 over a multiplied by x. There we go. And then minus. Now we do the second last integral. Now this is a trigonometric integral. So first of all, we multiply by negative 3 there. And then what's the integral? Of course, it's supposed to be positive sign. So it's going to be positive sign. But let's not forget we have x divided by 3 there. We also need to divide by the coefficient of x, which is going to be 1 over 3. So let's do it. 1 over 3. There we go. And then we do the last one. So the last term here, guys, is exponential. Now, first of all, we're going to write 3 to the power of negative 4x. And then we have to divide by the coefficient there, which is going to be negative 4. And then ln 3 plus c. So this here, guys, is the integral of all these terms here. So we need to create space so that you can simplify them further. Right. So let's continue. Now, if we start with the first term here, we know that we have to multiply these 2 with negative cos x. So our answer is going to be negative 2 cos x for the first term. The second term, we have to simplify it further. We have negative 2x to the power of half divided by half. There we go. Minus, we have 3x plus x over a minus, we have 3 sine x over 3 divided by 1 over 3 as well. Then let's look at the second last term. We have negative 3 over negative 4. That is going to give us positive 3. And then we have 3 to the power of negative 4x divided by 4 ln 3 plus c. Now, we have fractions here. We need to deal with these fractions. So what you can do here, guys, you can do this. The denominator of the denominator, it will multiply the numerator there. Same here. This 3 is going to multiply that 3 there. So let's continue. The first term is going to be negative 2 cos x. And the second term, like I said, 2 multiplied by 2, that's going to give us 4. X to the power of half. There we go. We have minus 3x plus x over a. And then this term here, the third last term, is going to be 3 multiplied by 3. That's going to give us 9 sine x over 3 plus 3 to the power of 4x divided by 4 ln 3 plus c. So this here is the final answer. I hope you guys managed to get this one. Really, this is a polynomial when it comes to integration, but it was not that difficult at all. Just in case you want to watch more videos on this type of polynomials, I will leave a playlist on the description, and also that playlist will pop up on the top right of this video. All right, guys, if this video helped you to understand, do not forget to like, share, subscribe, and also comment to the channel. If you got confused somewhere while we're busy with this, you can always watch at the point where you got lost. And if that doesn't help, leave a comment on the comment section and I'll try to answer you to my level best. All right, people, we are done with this question, which was 4.4. All right, guys, let's look at 4.5. Now, 4.5, they just want us to determine here. So we have this integral here. We just need to integrate, nothing more. So let's start. There's no simplification required here. We just have to integrate. I think the trick here is because we have fractions. So the first term we have 1 over 3, the coefficient. Now, what's the integral? Of course, we know that this is going to give us sine 2 over 3x. There we go. Then we divide by the coefficient there of x, which is 2 over 3 there. And then minus 1 over 5, the coefficient of sine there. So what's the integral of sine? So the integral of sine, we know that is going to be minus cos 5x divided by 5, the coefficient of x there, plus sin, right? Then if you continue, because this needs to be simplified, on the numerator we have 1 multiplied by sine 2 over 3x. So this is going to be sine 2 over 3x divided by, on the denominator we have 3 multiplied by 2 there. This is going to give us 6, right? Divided by 3, like that, right? And then the next term we have this minus and that minus. They're going to give us a positive there. If we multiply, this is going to give us cos 5x on the numerator, divided by, on the denominator we have 5 multiplied by 5. It's going to give us 25 plus c. So our final answer here is going to be as following. We have y is equaling to sine 2 over 3x divided by, what is 6 over 3? That is going to give us 2 plus cos 5x divided by 25 plus c. So here, this is our final answer for this one. So this was not difficult, but if you did not understand how to integrate the trigonometric ratios, it might get challenging. We have done the integration of trigonometric ratios on the playlist. You can go to our playlist and search for the integration of trigonometric ratios. You will see how we have done this one. I hope you managed to understand this, guys. If it so happened that you did not understand, don't forget to watch at the point that you got lost. But if you manage to understand, you can always leave a comment, like, subscribe, and also share the videos to your friends. We are done with 4.5. Let's go and do the last question, which is 4.6. All right, guys, here is our 4.6. Now here they want us to evaluate the following integral. Now this integral, it's really not that difficult as well. All you need to understand is that this is an exponential integral. So when we integrate the exponential integral, first we're going to write y is going to be equaling to the coefficient, which is 5 over 7 there. And then we know that e to the power of 2 over 3x. And then we must divide by the coefficient of x there, which is going to be 2 over 3 plus c. Now the next step, we just have to simplify. Now we continue on the next step by simplifying. We have to multiply this 5 with e to the power of 2 over 3x. So this is going to be 5 e to the power of 2 over 3x. And then divide by. Underneath there, we have 7 multiplied by 2. This here is going to give us 14 over 3 plus c. So we have a fraction under a fraction. So what can we do here? We can multiply this denominator with that 5 there. So let's do it. So our final answer is going to be y is equaling to 3 multiplied by 5. This is going to give us 15 e to the power of 2 over 3x divided by 14 plus c. So I hope you guys managed to understand this. It was not really that difficult as well. It's just that it had lots of fractions there. Just in case you don't know how to integrate exponential integrals, there is videos on our playlist. Go and search for exponential integration. You will see lots and lots of videos that are based on this type of integration. All right, people, we are done with this question paper. I hope you managed to pass this question paper. I had a comment from one of the subscribers that they managed to get 80% on this question paper based on the videos that I'm uploading here. So guys, we are done. Thank you very much for watching. Till next time. Cheers.